Automation and Aviation, a capstone PowerPoint presentation. The topics that will be presented are safety concerns involving both automation and pilots, how money plays an important role in safety, and how that role has supported the advancement of automation, how and why the number of pilot errors have increased over the last 70 years, how and why the flight crew are diminishing from the flight deck, and how proper training may help to keep the pilot in the cockpit. If airliners couldn't make a profit, there would be no need to operate in a safe condition because there wouldn't be a company anymore. This is why any proposed changes in commercial aviation are first scrutinized for a value of safe operations and also for a value to the company. Change has to either save money or make money. There are several issues that should concern any passenger today. For one, computers are as fallible as the humans who manufacture and program them. False positives in analytical circuitry, either in the collection or the interpretation of information, will lead to incorrect responses from the logic gates in the decision circuitry. Computers can also lose power or receive too much power from another component. For example, a faulty voltage regulator can take out a computer. Another concern should be that the computer can be hacked. Someone taking control over the computer to hijack the plane. Backup systems can alter the outcome of a single faulty computer, and the only successful attempt to hack an aircraft was done by the best IT technicians at the Department of Homeland Security. The aircraft had to be on the ground when it was done, and it didn't last for very long. What should be of more concern are the mistakes made by the most fallible component in the cockpit. As of now, the backup for the computer is the pilot. However, the pilot has been dependent on automation for so long that they've lost the skills required to fly the plane. It has also caused a lack of situational awareness for the pilot. This is creating a very dangerous situation that is now the dominant cause of aviation accidents. Automation in aviation began with simple instrumentation like altitude and airspeed indicators, then developed side by side with the aircraft during the Second World War, where pilots made use of simple axis controlling autopilots. In modern-day aircraft, computers not only control the attitude and position of the aircraft, but can also monitor all parameters and during all phases of flight, making the most minute deviations to make the flight more efficient and economical. Airline companies are looking hard at the potential for profit when the flight crew is no longer required. The number of revenue seats will increase, and the airline will probably charge more for front seat viewing of the flight. Airlines will be able to fly more aircraft per day at a much cheaper flight hour. In the beginnings of aviation, there were more mechanical failures. As the aircraft progressed through the years, improvements in design, materials, and technology have created a much more reliable aircraft. Mechanical failures decreased, however, human factor issues increased. The advances in technology have changed the active role of the pilot to a passive role, changing the pilot from someone who had command of the winds to someone who sits and watches the computer screen. As the pilot lost the will to pay attention and the skill to fly, human factor causation of accidents increased. In the past, the flight crew consisted of a pilot, a co-pilot, and an engineer, with the possibility of a relief crew depending on the length of flight. Automation has been able to monitor aircraft and its systems with enough accuracy and reliability that the engineer is no longer required by the regulating agency. Manufacturers have taken advantage of this space by removing the station in modern aircraft and saving the weight. Airliners took advantage and bought the modern aircraft and laid off all the engineers, except for those few air cargo outfits that still fly equipment like the 727 cargo conversion aircraft. At the present time, the FAA requires a pilot and a co-pilot for transport category aircraft to relieve each other of duties and share the flight load. Automation also shares that load and is engineered to be more reliable than ever before. Both Boeing and Airbus have the technology for a completely autonomous aircraft and are in the process of proving to the regulatory body that the first officer is no longer necessary. Then they will either get laid off or promoted to a primary pilot position. In the near future, will bring about a single pilot environment, and then the pilot's future will be in question. The computer has to be accepted as a valuable crew member. In order to make that happen, more research into the design of computers that will keep the pilot's attention with a better interface system that will maintain the pilot's attention will be required. Also, human factor training with an emphasis on HAT team training that includes onboard computers as one of the team members will also be required. In order to have a successful human-computer interface, the human in the equation will need a better understanding of the new crew member and learn to use it as it was intended, as a resource for the pilot, not an enemy of the pilot. Passengers are not ready to get on board an aircraft that does not have a human in control, even if he only appears to be in control. A pilot will be able to read a situation and think of a solution that may be outside the computer's ability to improv. The pilot is the one who puts his life on the line for safety and the future of the aerospace industry. It would be a mistake to fly without them. Thank you. The end.